Let's open object detection application code example. I'm going to use STM32 Cube IDE. So I'm opening the project, File, Open Project from File System, and then Directory. And now we need to navigate to the STM32 Model Zoo Services repository. So here, then we need to go to the application code folder, then to the object detection, N6 folder, then application, then decay board, because we are using N6 discovery board, and we need to select Cube IDE folder. So I need to confirm, and now I can dig into object detection example project. So I'm opening application subfolder and then main.c file, and also I'm opening app_config.h, so the configuration file for the project. And let's see what is in the header file. So we can see that the post-process type, and also following that default supported model, it is STYOLO-X UI. And our goal is to update this project with YOLO v2 model. By update, I mean update of the source code, and of course build and deploy. So let's come back to the main.c and scroll down a little bit. So here you can see again what is the post-processing and what is the model supported. Then we can see main loop. And for that, maybe for better visibility, let's come back to the slides, because I'm going to focus on the most important excerpts of the source code. So the first important action in main.c, it is the initialization of input and output buffer of the model. So here in the frame, you can see the source code excerpt. Then the next point worth to highlight, it is the main loop. In the main loop, we are waiting for the camera frame for the snapshot to be received. To remind you, 224 by 224 resolution. Then, when received, we are calling inference function. So we are performing detection of the object. Here you can see also the timestamps to evaluate inferencing time. And then after detection, when inference is ready, we are running post-processing of the output, and finally we are able to display the inference time. A very important point, as already mentioned, it is app_config.h configuration header file. So in this header file, we are configuring supported model. So not only the model itself, like here, STYOLO-X UI, but also input picture resolution, also number of classes, name of classes, for example, maximum number of boxes of the detection frames to be displayed, etc. I would like to highlight here that especially the post-processing parameterization is relevant for given model. So what is visible here on this slide. So here you can see, it is also an excerpt of main.c, the list in the source code of supported model. The active one, it is YOLO-X. However, also YOLO v2 is supported, YOLO v8, YOLO v5. And if you would like to integrate your own custom model, you must implement your own dedicated post-processing chain. This is very important point. As you can see here, if the model is not on the list, the error message is displayed. Then regarding discovery board, of course, camera must be connected. Camera is a part of discovery board, 5 megapixel. So here you can see how to connect camera using flat cable. And then regarding the discovery board itself, from the practical point of view, important point, it is the configuration of the boot mode, as you can see on the slide. So development boot mode means that boot 1 and boot 0 switches are on the edge of the board. The boot 1 switch must be switched to the H position, must be moved to the edge of the board, and the flash boot mode, it is shown here. So it is opposite position of the boot 1 switch comparing to development boot mode. Both boot modes will be used when we execute the deployment script.